So I'll talk about work with Weisel from Tel Aviv University, and what I'm presenting here is about to come out as an opinion piece in Frontiers in Psychology, and it's based on our older, one old, one new experimental papers, as you'll see. Okay, so this is where we start from. This is more than 100 years old quote. Exigencies of war with outsiders are what makes peace inside. This is also referred to as the common enemy effect or the conflict cohesion series, right? We know that if our group is in conflict with another group, then there's more social cohesion within the group, we cooperate more. What we are saying is that first, an observation. Under some situations, we see the opposite. When there's outside threat to the group, we see less cooperation. We want to argue that we can explain this with a perceived level of threat, as I'll explain in a minute. And then we go to the lab and test it in clean experimental games. So some examples. First, regarding mobilization in conflict. The rally around the flag effect is well known. For example, after 9/11, 20 years ago, there was lots of support for President Bush, which enabled going to the Iraq War in 2003. On the other hand, there's a negative association between personal ties to casualties of the 9/11 events and support for the war. So we see that people who should feel more under threat because they have more close ties to the event, they tend to support less. So we see the opposite effect. We see similar effects, similar phenomena with natural threats, like hurricanes, natural disasters. There's lots of literature on that. After natural disaster, the community comes together, there's social cohesion, people help each other, there's cooperation. On the other hand, after a while, we see erosion of social support following these events. There's also a result that we see this in small-scale disasters, but in major disasters, we see the opposite. There's a nice paper, recent paper by Barbie and Yona about mass shooting, which is not a natural disaster, but sort of has a similar characteristics. It's a singular event, it's not ongoing. And they find that there's less cooperation in the locality where the mass shooting happened, but there's more cooperation in terms of charitable giving, that's what they're measuring, in the surrounding localities. And so again, we see a positive effect and at the same time a negative effect. What we suggest based on our previous research is that what's going on here is on which level do people perceive the threat? Is it a threat to the group or a threat to the individuals in the group, right? And this is the idea. If I feel that the group is under threat, my group identity is strengthened. I feel the common enemy where we have common fate, and I worry about the group. I do what's good for the group, which is cooperate. But if I feel that I'm personally under threat, I do what's good for me, which means not cooperate. So we can see the opposite effects. And this can be the same threat, right? So for example, if there's some event, like with the mass shootings, people who are in closer proximity, they're not affected more than people, few 100 kilometers away, but they feel closer to it, they feel the threat more personally, and they cooperate less compared to the people further away who cooperate more because they perceive it as a group thing. And what we did was get into the lab, and there's a long literature starting with Gary Bornstein's pioneering work in the late 80s, early 90s, getting intergroup conflict and bringing it into the lab using experimental team games. And what we do is we follow this literature, but we vary how people perceive the same experimental game, whether they perceive the threat at the group level or individual level, and see what happens to behavior. So let me explain how this works. So the 94 paper by Bornstein and Ben Yosef compared the PD, the prisoner's dilemma game, with the IPD, the intergroup prisoner's dilemma game. The PD here above, see, here I can. We have three people, it's a three-person prisoner's dilemma game. Each group member decides whether to contribute to the group or not, cooperate or not, And the payoffs depend on the number of contributors in the group, which we have here in the columns, and whether this person contributed or not. Right? So for example, if only one person contributed, then this person gets 12, and the other two who didn't contribute get 17. Right? In the intergroup prisoner's dilemma, all of this is embedded in intergroup conflict. So we have now two groups with 3 members in each group, and what we have in the columns here is not the number of contributors in the group, but the difference in contributions between my group and the out group. So for example, if in one group there are 2 contributors and in the other 1 contributor, then in the group with more contributors, the balance is +1, right? So we're looking at this column. And in this group, the 2 contributors get 12 and the 1 defector gets 17. For the other group, the group with 1 contributor, the balance is -1, right? It's -1 contributor less than in the other group. This contributor gets 6 and the 2 defectors get 11. Now, the beautiful thing here, this was Gary Bornstein's beautiful idea, that the prisoner's dilemma game is embedded within the IPD. So you can see from these payoffs that if nobody in the other group contributes, then the balance is 0 to 3, and we are back exactly with the same game that we had in the prisoner dilemma. So if we compare behavior across these two games, then we can really see the effect of conflict, pure effect of conflict. All the incentives within the group are exactly the same. Contribution, cooperation is costly. It's good for the group. That's the same in both, but only in the IPD, it's embedded within conflict and it harms the other. Now notice that we can tell this story in a different way. Let's see if I can erase some of my scribblings here. So we can think about the PD game as you get 14, right? You can contribute, the cost of contribution is 5, so you lose 5 and everybody in the group gets 3. So you lose 5, you get 3, in total you lose 2, right? So 1 more contributor, you move 1 column to the right, but you move to contribution. From contribution, you only lose 2. But this can be seen as a public good where you can get 5 if you keep your contribution, or everybody in the group gets 3. Let me show you this graphically, right? So here on the left-hand side, we have the prisoner's dilemma. People choose between a private account and a group account. They can get 5 from the private account. If they contribute to the group account, they get 3. They don't get a 5, but everybody else in the group gets 3. In the IPD, they choose between, again, a private account or a conflict account, where within the group it's exactly the same. They can get 3. Everybody in the group gets 3. But this comes at a -3 to the out group. Now note that if we present the game this way, we look at the comparison between 2 groups. So the threat, what the other group does, harms us as a group. But if we present it this way, it harms each individual separately. So this is how we manipulate the perception, but the game is exactly the same. This is the data for pro-social from our 2016 paper, and we see exactly what I talked about. Under group threat, with conflict, you see more cooperation. Under individual threat, with conflict, you see reduced cooperation. So we see this in a very clean way in the lab. In our newer paper, soon to come out in OBHDP, we actually looked at a different game, but we also have IPD. So this is not a result that appears in the paper. This is only part of this talk. But we had the IPD with people chatting among the 3 people in the group before playing, and we had this chat rated by independent judges. What I want to look is when they talk about defense motives. So defense motives are positively correlated with contributions when the group is presented, when the threat is presented at the group level, but we see a negative correlation under the individual frame. The defense motives are associated with lower contributions, lower cooperation. So this is again exactly in line with our story. Okay, so just to wrap up, we see, looking observationally, that external threat can lead both to higher cooperation or lower cooperation. And what we think is the psychological mechanism going on is conservation of resources. So conservation of resources theory states that, I'll read, when confronted with stress, which is the threat of a net loss of resources, individuals are predicted to strive to minimize their net loss of resources. Our contribution is we say here, hey, if we think of social identity theory and we think that people think about the group identity as part of their identity, and then we apply the same principle, then we can get the common enemy effect. So just say when the group is confronted with stress, then the group members are predicted to strive to minimize net loss of resources, which means doing something that is costly for them by cooperating. So we can get exactly the opposite, depending on whether people think about their individual identity or the group identity, which in turn depends on the level on which they perceive the threat. Okay, and that's it. Thank you.
Thank you very much. I think we have a couple of minutes for questions. If you have a question, feel free to raise your hand.
Okay, I see comments in the document, in the Google Doc.
Yeah.
So Iraq was not behind the 9/11, yes, but we know that the support for the war, 9/11 made it possible to go to war, even if it doesn't make sense. Okay, but again, this is just an example. And there are many other examples.
If no one else has a question, I actually have a quick question. So I think your model is primarily built on a one-shot prisoner's dilemma game, right? So do you think you will observe the same effects if it's an iterated prisoner's dilemma game? So if the same group of people interact several times instead of only once?
So what I can say is that I haven't shown our results with the IPDMD, a different game. So we didn't try manipulating the framing with repeated games, but with these games that were separately studied under the group frame and under the individual frame, there are papers doing it repeatedly, and there's nothing new going on when you do it repeatedly. So that's what I can say.
Mm-hmm. Okay, thank you.
I would have a question maybe. Is there a way to manipulate how much a person feels that his group is under threat, or if it's more individual threat?
So that's exactly what we wanted to do by the changing the frame. I didn't show you the instructions, but basically in the IPD, you can say if you contribute, everybody in the group gets 3, and everybody in the outgroup loses 3. Or you can, the same equation you can state by, let's take contributions in the group minus the outgroup and multiply everything by 3, instead of multiplying each separately by 3. So this, mathematically, this is a very trivial difference, right, that you learn in grammar school. But turns out that if we just explain the instructions this way or that way, it makes a huge difference, and we get actually the opposite effect. And that's the idea. What we're saying is that then if you separate it, then you don't get this common fate effect. So people don't perceive it at the group level. But that was the idea. We changed the framing of how we explain exactly the same equation. And by that, we changed the way they perceive the game, the level they perceive the game.
Okay. Thank you very much again.